Today's video is from the complex power series, and today's topic is singularities and different types of singularities. So this is the most important question, and let me explain you about the singular point. So a singular point or the singularity of a function f of z is the point at which f of z is not analytic. So, if you clearly examine this one, the point at which f of z is not analytic, so that point is called the singular point. The point at which f of z should not be analytic. And here, example, f of z is equal to 1 by z. So, if you keep z is equal to 0, so 1 by 0 is infinity. So, f of z is an undefined function. So, it is not analytic at this particular point, z is equal to 0, and this z is equal to 0 is called the singular point for the function f of z. And next, for the second example, f of z, this is 1 by z minus 2. So if you equate this denominator to 0, z is equal to 2. So after substituting z as 2, 2 minus 2 is 0. Again 1 by 0 is infinity. F of z is an undefined function. F of z is not analytic at this particular point, z is equal to 2. So if you take 3, 4, 5, 6, any number other than 2, so this function is analytic. So at this particular point, f of z is undefined and not analytic, and that particular point where f of z is not analytic is called a singular point. Clear? And next, after learning singular point, so they are different types of singularities, and see, these are the different types of singularities. So singularities are classified as an isolated singularity, non-isolated singularity, and further isolated singularity is classified as pole, essential singularity, removable singularity. See here, I have explained what is a singularity. So a single point at which f of z is not analytic is called a singular point. And next, coming to isolated singularity, so let me explain you what is this isolated singularity. So here, isolated singularity, see, you have heard about isolation. So when a person is attacked with the covid or coronavirus, he is isolated so as to save the other persons from that virus. See, in this particular case also, a point z is called an isolated singularity of an analytic function f of z. See, a particular point is isolated so that to make the function analytic, if this point is there, so f is not analytic at that particular point, z is equal to a, and f is analytic in the deleted neighborhood of z is equal to a. Clear? What is an isolated singularity? The point z is equal to a is called an isolated singularity of a function, analytic function, if f is not analytic at z is equal to a and f is analytic in the deleted neighborhood of z is equal to a. See, which means f of z is equal to e power z by z square plus 1. If you equate this denominator to 0, z square plus 1 is equal to 0, then z square is equal to minus 1 and z is equal to plus or minus I. So at plus I and minus I, if you substitute, the whole function is undefined. So it is not analytic at this particular 2 points, plus I and minus I. In the deleted neighborhood, see, the neighboring point of I is 2I. See here, minus 2I, minus I, minus 2I. So these are all the deleted points, so neighboring points of I. So at, other than this point, if you keep, so for plus I, it is not defined. So for 2I, it is defined. If you keep 2I, so it is not going to be undefined. So it is going to be analytic, and at this particular 2 points, plus I and minus I, the function is not analytic. At not analytic at particular z is equal to a. Here a is nothing but plus I and minus I. So we have to isolate these points in order to make the function analytic. So z is equal to plus or minus I are the two isolated points of f of z. And next one, f of z is equal to 2 by sine z. See here, we have to equate this denominator to 0. So when we'll get z0, sine 0, so it is sine n pi. So for sine n pi, it is 0. So all the z values, so z values is nothing but n pi, that is plus plus or minus pi, plus or minus 2 pi, plus or minus 3 pi. See here, plus at each and every point, infinite number of points, f of z is undefined, so not analytic at those points, and it is analytic at the particular points. If you keep z is equal to this pi by 2, so this function exists and this is analytic at that point. So whereas if you keep z is equal to pi, z is equal to pi, this is undefined. So they are infinite number of isolated singular points. See here, they are singular points, there are finite number of singular points and infinite number of singular points. So we isolate that point in order to make the function analytic. So coming to, see here, after singularity, definition of singularity, isolated singularity, and next pole, essential singularity, removable singularity are the types of isolated singularity. See here, it is also very clear. So here, if you select this one, so it is a contour at which, at a point or plus I or minus I, so this point f is not analytic. It is not analytic. And in the particular neighborhood 2i, 3i, 4i, 5i, at this neighborhood, so f is analytic. See, f is analytic. See, if you consider this point, so we have to isolate this point as it is not analytic. So isolation is made to this point for which f is not analytic. So here, if you observe this one, in the neighborhood it is analytic, in the particular point it is not analytic. So this is like a concentric circle having center, same center, different radii. So this is, so now if we want to define the function, we are going to use Laurent series. For Taylor series, we need the entire contour. So for each and every point, it should be analytic. So here we have deleted this point, and the rest it's like a concentric circle, angular ring. So this is like the ring shaped structure. Therefore, I am going to use the Laurent series. If z is equal to a is an isolated point of an analytic function f of z, then f of z can be expressed in the Laurent series about z is equal to a. So this is the expansion of Laurent series. F of z is equal to sigma n is equal to 0 to infinity an into z minus a power n plus sigma n is equal to 1 to infinity bn by z minus a power n. So here the negative integral power of z minus a, namely sigma n is equal to 1, sigma n is equal to 1 to infinity bn by z minus a power n is called the principal part. So this part is called the principal part. So as I am using the Laurent series for this expansion, and this negative power of z minus a is called the principal part, and depending upon this negative part, we are going to classify isolated singular points. See here, isolated singular points. So depending upon this principal part, isolated singular points are classified as pole, essential singularity, removable singularity. So what is this pole? See here, pole is nothing but if this principal part contains a finite number of terms, then the singularity z is equal to a is called a pole. See, if this expansion is finite, if it has a finite number of terms, it's going to become a pole. So if the principal part contains an infinite number of terms, then the singularity z is equal to a is called an essential singularity. See here, if the principal part contains no terms at all, then the singularity z is equal to a is called the removable singularity. So types of isolated singularities are pole, essential singularity, and removable singularity. If the principal part contains finite number of terms, it is a pole. If the principal part contains infinite number of terms, it is an essential singularity. If it contains no poles, so it is removable singularity. Example, f of z is equal to z square by z minus 1 into z minus 2 square. So here if you equate the denominator to 0, z is equal to 1 is a simple pole and z is equal to 2 is a pole of order 2. So these are the examples of pole. And coming to essential singularity, so it should contain infinite number of terms. So 1 by sin z. So if you equate sin z to 0, so this will be plus or minus n pi. So n is equal to 1, 2, 3 and so on. Here there are infinite number of terms here. So these plus or minus 1, plus or minus 2 and so on are called, here essential singularities. So this type of singularities are called essential singularities. And next, coming to the removable singularities, see f of z is equal to sine z by z. So for the expansion of sine z, this is z minus z cube by 3 factorial plus z power 5 by 5 factorial and so on by z. So I removed this z. So in order to make the function analytic. So here I removed z here, and therefore this kind of singularity is called the removable singularity. Clear? So it is very clear. Isolated singularity, there are three types, that is pole, infinite singularity and removable singularity. So pole means, so pole, if it contains finite number of terms, if it contains finite number of terms in the principal part, then we say that it is pole. If it contains infinite number of terms in the principal part, then we say that essential singularity. If there are no terms at all, then we say it's a removable singularity. Isolated means the point which is deleted from the function. The whichever the point is deleted or isolated, so that particular singular point is called an isolated singular point. And next, coming to the non-isolated singularity. And see here, this is also very simple. See here, a non-isolated singularity, a singularity z is equal to a of f is non-isolated. It is not isolated. So it is in the function itself. If every neighborhood of z naught, if every neighborhood of z naught contains at least one singularity of f other than z naught. See here, other than z naught. See, every point should be existed in this function. Z is equal to z naught is non-isolated. It is not isolated. If every neighborhood of z naught contains at least one singularity of f other than z naught. Here, the limit point of pole. So after finding the limit point of the pole, it will be the non-isolated singularity of that particular point. For example, f of z is equal to 1 by sine pi by z. So if you equate this denominator to 0, see here. So when it will become 0, so for n pi, so this is for n pi. So if you equate pi by z is equal to n pi, and after cancelling pi, so n is equal to 1 by z. So we need the value of z. So z is equal to, see here, this is 1 by n. So so the limit point of this z is equal to 1 by n will be the non-isolated singular point. So if you find the limit, that is limit n tends to infinity of 1 by n. So 1 tends to infinity. So 1 by infinity, the value here is 0. So here 0 is a non-isolated singular point. So clear? After getting an idea that a singular point, it is never isolated. If the every neighborhood of z naught should contains at least one singularity of f other than z naught, except z naught, every neighborhood should contain at least one singularity, and the limit point of the pole is always after finding the limit. So we have to find the limit for this one, and that limit point is called a non-isolated, and it should contain an infinite number of terms. So here, hope you all got an idea on singularity, types of singularity and types of non-singularity. See here, types of singularity. So first one, what is a singular point? Singular point is nothing but the point at which f of z is not defined. The point, the particular point f of z is not defined is called that singular point. There are two types, isolated singularity and non-isolated singularity. What is this isolated singularity? Isolated singularity is nothing but, see here, isolated singularity is nothing but, so we have to delete that point in order to make the function analytic. So at a particular point, f of z is not analytic. See here, the point which we isolate to make the function analytic is called isolated singularity. And isolated singularity, so the point which we are deleting here is, so the point which we are deleting from the entire contour in order to make the function analytic, and that particular point is called isolated point. And here if you observe this one point is deleted, so here is some gap here. So this is an angular region or concentric circle. Here is a ring shaped structure, and for the ring shaped region we use the Laurent series for expansion, and this will be the principal part, and depending upon the principal part, so here isolated singularity is classified. Here, if the principal part has finite number of terms, it's pole. If it contains infinite number of terms, it is essential singularity. If it has no terms, it is removable singularity. And coming to the non-isolated singularity, see here, a non-isolated singularity is the point at which it contains, every neighborhood should contains at least one singularity, and the limit point of that pole is always a non-singularity. For each and every term definition, I have given one example. Please go through this video, and it is very useful, and this is the most important topic and repeatedly asked question. If you really like this video, please share it with your friends, spread knowledge, and please practice and go through the playlist once for more videos. Thank you so much.